This is a video for MEI Core Pure Polar Coordinates, Section 1.4, Finding the Area of Polar Curves. We should know that the area of a sector is equal to a half r squared theta, where theta is measured in radians. If you look at the sector over here, that's actually a fraction of a whole circle, and it's theta over 2 pi of the whole thing. So if we look at the area enclosed by a polar curve, we can think of it as the sum of lots and lots of small elements. If you look at the red area on the diagram here, I've drawn in a small blue element with an angle delta theta. This is approximately a sector of a circle, so the area for that is going to be a half r squared delta theta. But then I'm going to take an infinite sum of all the possible elements of this type, and that infinite sum becomes this integral here. You can find fuller explanations for this in your textbook. Let's have a look at the area enclosed by the polar curve r equals sine theta between theta is pi by 6 and pi by 3. For that curve, r equals sine theta is the circle, and there's the area I'm interested in between pi by 6 and pi by 3. We know that our area is equal to the integral between pi by 6 and pi by 3 of a half sine squared theta d theta. Remember, it's a half r squared d theta. Now, integrating sine squared, we can't do directly. We're going to use the double angle formula. So this becomes a half times the integral between pi by 6 and pi by 3 of 1 minus cos 2 theta all over 2 d theta. Working that integral through, I'm going to get a half theta over 2 minus sine 2 theta over 4. And that's evaluated between pi by 6 and pi by 3. Sticking those limits in then, I'm going to get a half of pi by 6 minus root 3 over 8 from the upper limit, and then from the lower limit I'm going to get pi by 12 minus root 3 over 8. And so altogether this comes out to be pi over 24. There's that written out for you a little bit more tidily. You can see here we've got our area is half sine squared theta d theta integrated, double angle, work through the integration and come out to this value. Is the answer reasonable? Well, pi over 24 is kind of close order 1/8, and the circle is radius a half, so pi r squared, it's a quarter pi for the whole area, and a quarter pi is about 3/4, so this looks to be about a 1/6 of the whole area, which looks reasonable. That was the final video in the section Polar Coordinates.